The motivation behind Ride+Safe project concerns the alarming rate of motorcycle accidents on our roads. Research has shown that ergonomics plays an important factor for the motorcyclist to maneuver his or her motorcycle. Within this context, University of Malta, in collaboration with WKD Works, have joined efforts in order to develop an innovative motorcycle simulator. The innovation behind this motorcycle concerns the adjustability depending on the size of the person. We aim to install this artifact in showrooms in order for motorcyclists to take an informed decision on which motorcycle best meets the ergonomics of the customer.
Motorcycle manufacturers usually roll out a standard bike from the factory. The end user is not standard. You can have a rider that is 5 foot tall, you can have a rider that's 6.5 feet tall. They are both riding the same bike. Is it comfortable for both? No. So what this will allow us to do is to modify the vehicle to tailor fit the end user. This with the aim of making the ride more enjoyable for the user and hence safer. It will allow us to experiment what is best for the rider before we actually implement the change. So it will help us both economically and also save us time that nowadays costs money.
The Ride+Safe project first kicked off by first analyzing our users' problems. Our primary users are the motorcycle designers, customizers, and builders, with the ultimate aim to eventually help the motorcycle riders. The solution was composed of two parts. The first part is the ADAMS, an adjustable motorcycle jig, a standalone, which is composed of the mechanical jig, the hexapod, and the simulation environment. So the motorcycle jig has the ability to adjust and has more than 12 degrees of freedom for adjustment. For example, we have handlebar height variation, seat variation, foot pegs variation. Okay, so ultimately this we can simulate small motorcycles such as scooters and also large motorcycle cruisers. The hexapod gives the motion to the mechanical jig as it is a simulator, and for the virtual environment we opted to build from scratch the coast road so that when the riders are simulating on ADAMS, they have a familiar environment. Lastly, the ADAMS is also incorporated with a software script where we can translate and map the measurements on ADAMS with those of real motorcycles and vice versa. So the second part of the solution was an artificial intelligence software package which, using the rider's anthropometry, the measurements from the jig fed into this algorithm, the software can help designers and motorcycle builders to develop safe motorcycles from an ergonomic aspect.
One of the important aspects of this project were to try and make the experience for the rider on the jig over there to be more realistic and more immersive. So in addition from having the visuals on the monitors and the sound for the simulation, we would also like the rider to experience a sense of movement, a sense of motion, as if one would have from the actual sensations of riding a real motorcycle. Now, the problem is that the actual movement in this setup is limited because we are constrained by the extension of these legs over here, basically. So how could one convey such sensations with a limited motion? So we exploit what is called the vestibular system, which is basically a physiological system in our head, which conveys sense of balance and sense of motion to human beings. And we try to move the platform in such a way to sort of trick the vestibular system into feeling similar sensations as what one would normally feel when having a normal motorcycle ride.
The funds received from the Malta Council for Science and Technology under the R&I Fusion program enabled us to recruit a number of postgraduate students working in the field of product design and control system engineering. Furthermore, such funds enabled us also to disseminate our results in peer-reviewed conference and journal publications. Last but not least, these funds helped us also to file a patent at the UK Patent Office.